Merci Clément, bonjour à tous. So, for many, the future looks a bit like this. So we're talking about human beings entering cyberspace and interacting with digital entities. Now we think it's actually going to be rather the opposite. Digital entities interacting in our realm using physical objects, autonomous objects. Now, blockchain, as Joseph just explained, brings transformation to fields that may not be as, I'd say, sexy as VR headsets. But these verticals form the backbone of our connected digital society. So what we're trying to achieve at Slock.it is marrying the physical and the digital. And the way we do this is obviously using blockchain. So the blockchain is this series of smart contracts, of autonomous digital entities. They can talk to each other, they can transact with each other, they can send money to each other. And because they're based on the blockchain, they benefit from all of its properties. Immutability, meaning that a third party cannot arbitrarily change a smart contract on the blockchain. They cannot go in there and change the data that's in the database, if you will. It's there forever. It's therefore corruption-proof, and it's resistant to collusion because it's based on a network formed around the principle of consensus at scale. And it benefits from cryptographic security by design because Ethereum was built on public and private key infrastructure. And finally, this is, by the way, quite amazing. These are applications that have zero downtime. So the decentralized app that we just learned about, they never go down. And that's because they operate on a network that's formed of thousands of nodes and eventually millions. And even if you were down to 2 computers, they would still function. And they also give access to their user to something what I call zero sign-on. And we'll get to that in a second. So what we're trying to achieve is really marrying the blockchain, and our space by establishing a one-to-one relationship between objects and their digital counterparts that have unique identifier. And it's these digital identifiers that we use to make that relationship. And effectively what we're doing is we're giving objects an identity. We're giving objects all the properties from the blockchain. They inherit it, so security, immutability, etc. That's all part of the object now. And of course, we're giving the objects the ability to run code. So think about that, objects that can run code. Objects that are fully autonomous, objects that can actually own themselves. Let's take a use case. So we have our user, Bob, and typical use case is looking for a house to rent. So what he does, grabs his cell phone, loads up a decentralized application, and this is the zero sign-on I was talking about. He broadcasts a unique digital identifier that represents him on the network, just like the smart contracts have a digital identifier. He broadcasts it, and therefore the application knows who he is, because only the person who holds the private key matching this public key can sign these transactions. So the network for sure knows that it's him. He doesn't have to register. He doesn't have to sign on. Another advantage of decentralized applications over the web. He finds the house. He loves it, of course. Now, the phone is going to connect. I should say the application is going to read the blockchain, identify which contract, which represents the door for that house, and sends it a transaction. It sends it money. It sends money to the door. And if you were to look inside that smart contract, what you'll find is it's really a row in a database, right? Smart contracts are fancy Excel spreadsheets with macros attached. And if you were to look in there, you'd get this row, and you have the user unique ID in there, how much they paid, the duration for which they're allowed to stay in that place. So we're establishing this one-to-one relationship. We give the object their identity. The objects are fully autonomous. The user arrives. We talked about this already. I'm sure they can edit this in post, right? So the user broadcasts, again, a signal, and eventually he's going to arrive at the door. Unfortunately, I can't skip any of this, so you're going to have to watch it again. Sorry, guys. Identifies the door. Sends it money, it gets recorded. Right. Once it's at the door, well, actually, first of all, what we've established here, by the way, is a smart contract, a contract between human and machine, right? Which is quite special because the human obviously has the only unique ID that corresponds to what's in the contract, and the door is the only entity that can open or close that door. It's the door's choice to decide whether or not the door will open. There are no third parties. There are no centralized third parties to levy heavy commission fees because they have a captive market or anything like that. There is no possibility of censorship. So this door that we just looked at, it could be in North Korea, and one of you guys in this room could be renting it. It transcends jurisdiction and it transcends borders. The user arrives at the door, he loves the place, of course, and then he grabs his cell phone and he knocks on the door. He knocks on it virtually by communicating to it wirelessly, and he broadcasts his unique ID that represents him on the network. The door then, unsurprisingly, connects to the blockchain, reads from the blockchain, identifies the contract that represents itself, and sure enough, we have our database row in there. And it checks that the ID that's inside the smart contract matches the ID of the user that's at the door. It's a match. The door opens. The user comes in, and he loves it. Right. So that's what we're trying to build at Slock.it, right? We're building practical solutions, pragmatic applications that have practical usage today of the blockchain in the real world. Why? Because we believe that transacting with autonomous machines will soon become the new normal. And why wouldn't it be? Now, we saw there was a smart contract in the blockchain that represents our door, right? But what if there was a smart contract that represented the cleaning service so that it could be automatically notified if someone is coming and going out of that apartment and optimally schedule around these things? Be immediately notified that somebody is overstaying at the Airbnb and come a little bit later. So a contract between the cleaning company and the Airbnb itself. What if we could connect utilities to the blockchain? What if we could have gas, water, electricity all in there? I know I don't use Airbnb like everyone else. I don't cook, for example. I don't use gas and electricity there. Why would I pay for this stuff? So we're starting to form this picture of an Airbnb that's fully autonomous, right? An Airbnb that just functions on its own without any human intervention. And to complete that picture, we need an insurance to make sure that nothing untowardly happens. An insurance where the person renting only pays for the duration during which the apartment is in use. And we're already doing this. So we have a partner called Electron to help us on the utility side of things. And we're working with a company called SafeShare to provide this ad hoc insurance to people renting apartments directly on the blockchain. So the next project I'm going to show you, I think, is going to blow a few minds. This is a completely autonomous drone. It's a car, obviously, four-wheel car. And this car is currently, we're working with this company called Venco, by the way, as part of a project called Mobilic, to integrate the technology you just saw as part of those mobile vehicles. Why? Because the logical conclusion of the driving car is the self-renting car. This car, you can buy 4 or 5 of these things for the price of a brand new sedan. So it's affordable. And the idea is for people, communities, to buy these cars, deploy them in their neighborhoods, and have the cars work on their behalf. They're fully autonomous, they drive themselves, they're easy to repair because they have a modular design. Of course, they will accept cryptocurrency, and users will only pay for the kilometers that they use. So you have a true Uber killer on your hands here. Now, the next step is how are you going to charge these things? So today we're announcing that Slock.it and RWE are partnering on a project to study the possibility of integrating blockchain and charging stations. If you don't know RWE, they're a giant German electricity power company. They're known as npower in the UK. And these guys are the most transformational open company I've ever worked with. They upfront on the internet, it's on YouTube, there's a chap called Carsten Stocker, who's their head of blockchain technologies, who outright says, look, we're hurting, we're losing money. We had to close nuclear power plants. I mean, that sounds pretty bad, right? We need solutions, and as part of the solution enters blockchain. So we're working on this demo, and I'm not going to show the entire demo here because we're out of time almost, and on top of that, I couldn't carry that huge charging station. It was a bit too big for the suitcase. But what you're looking at is a user renting the charging station, entering a contract with it, renting its time, plugging in the power plug, charging his car. A transaction is sent to the Ethereum network. By the way, all this was recorded live at the time, and this is a real practical example. We have it running in our office in Mittweida in Germany. So the user charges his car, and then eventually what will happen is the car will be fully charged, the guy disconnects, and he has paid a deposit, the money is sent back to the user. This is quite special because usually if you rent electrical cars, I don't know if you have one, but you usually rent by the hour. In this case, you're renting by the amount, the watts that you're consuming, so it's more optimal. And it's a contract between the human and this RWE machine, which works on behalf of the energy company. So why do this? You know, why bother with this blockchain stuff? Why not do it all centralized, right? Surely you can do it centralized. Of course you can, but with blockchain, you benefit from multiple of things. So first one is simplified billing. Now, I used to work for a company that was part of Visa, and we used to do a lot of billing systems between loyalty programs where you have a point system, and the point system varies per jurisdiction, and then there's things that can't have points and others that can have points, and they all sit in different databases. I mean, basically, the thing was a mess. I wanted to bring it to you here today, but I was told I'll get into trouble if I did that, so I brought the next best thing, the drug flow supply chain in Zambia. Now, I had a diagram like that, and it seriously looked exactly the same, and I learned to love it for a couple of years. But simplified billing between party and counterparty is one of the main advantages of blockchain. The next thing we're trying to achieve is we're trying to get rid of the centralized server altogether. In order to use blockchain properly, you need to only pay for what you use, right? You consume resources out of the world computer that Joseph was describing. It's a computer that we all have access to. You can be a small company, you can be a big company, you can be an individual. We all have equal access right to this world's computer. And so we only pay for what we use as part of this pool of resources, this database. So in a nutshell, your point of sale, your billing system, your partners, your accounting, your finance, your analytics, all of that stuff is going to eventually coordinate around a blockchain state and operate as part of an optimal economy of objects and services, an economy of things. So there's the Internet of Things, it's going to be the economy of things. And it's going to make onboarding channel partners a breeze, by the way, because now they benefit from this open API. No more service-oriented architecture with impenetrable APIs, things like that. That's over. It's all open now. Fraud-proof accounting. Now, I'm not going to spend too much time on that. I think it's pretty obvious. But no more cheeky phone calls at 2 a.m. From one department manager to another saying, hey, Bob, can you drop a few rows from this transaction table, please, because my boss says so. I mean, you're laughing, but I've seen it happen. All the transactions in the blockchain are immutable. This accounting is going to be fully transparent, by the way. So in the future, this could come handy for some regulation issues. And the last example, it ties it all up nicely. So you got cars, you got a traffic light, right? The cars are waiting at the traffic light, nothing special. But they're electric cars. Induction plates under the cars, charging the cars while they wait at the traffic light. That's another project that we're working on with RWE. And I think it puts things nicely together. So you got this simplified billing, and you got this unique ID that comes back and identifies the user so they can pay for only what they use, those microtransactions while they wait, and then they move on. So the blockchain isn't a panacea, if you will, far from it, but it allows all those verticals to come nicely together and operate fluidly around this economy of things. So unfortunately, we're out of time for any other example. We have a blog and a website. You can check it out. The URL is on the screen. There's more use cases there. Thank you.
So really interesting.
Thank you.
One question, same as actually what we were talking with Joseph. How does Slock.it is trying to build its ecosystem? Because I think that's something that's been really interested, and we've been really exciting to look at how you've been doing it.
Yeah. So all the work that we're doing is open source. So all the stuff that you've seen, including the prototype door that was in the video earlier, that's open source. You can go on GitHub, you can download it, and you can play with it, and you can build your own objects and participate as part of what we call the DAO, which I imagine is going to be your next question.
What's a DAO?
What's a DAO? So DAO is a decentralized autonomous organization. It's a series of those smart contracts you've seen earlier. It's fully autonomous, and it's kind of like a company on the blockchain. there's not that many around. Primavera is going to show one after myself, after this presentation. But it allows for a completely transparent accounting model at the corporate level itself. And in effect, what we're doing is, historically, we automated the workers, and now we're automating the bosses. So that's what a DAO is. And we're putting one together in order to kickstart our project.
So basically, you are building a company, and the company by itself will be able to fire you and put you out of business.
Pretty much. So they're hiring us the DAO is hiring us as a service provider because we think we're going to do a good job. But if we don't do a good job, if we're pictured, I don't know, driving Ferrari somewhere in Geneva, for example, they fire us. Simple as that. And they keep all the money that they've put in so far minus what has been sent to the initial service provider. So it's a better model than a Kickstarter. It's not fully autonomous just yet because it still requires those token holders, if you will, to take decisions, and these guys are humans. But long term, over a certain iterative process, we hope to automate this.
Cool. Thanks so much, Stephan.
Thank you very much.
See you.
Cheers.